We're asked to factorize this expression 10xy minus 2x plus 5y minus 1. Now we can think along similar ways to normal factorizing when you just have an x in there. Okay, it's a little bit more complicated, but it is the same concept. And it must be, if we're going to get minus 1, that we're going to have a 1 and a minus 1 in there. And that sets the ball rolling, because now if I want a minus 2x, well, I think the only way I'm going to get that is if I put 2x here. That's going to give me minus 2x. This is a plus. And then if I want 5y, that's going to be 5y. And then if we times these two together, we do indeed get 10xy. So that's our factorization. It's a slightly different approach to when you're just factorizing a normal quadratic, but there are some similarities in there as well. In part B, we're asked to use this factorization and considering factor pairs of 99, find all integer pairs x, y such that this is equal to 100. So they've given us quite a bit of a few hints here. And it says enter y values only on the answer sheet because I think in this paper that it was an answer only paper, but I'm gonna write down both answers. Right, so I've got that this is equal to 100, so we can write down that 10xy minus 2x plus 5y minus 1 is equal to 99. Okay, I've just minus 1 from both sides, and that's now what it's talking about, finding factor pairs of 99. Actually, I'll talk about that in a second. Yeah, this is quite nice because often when you try to solve equations like quadratics, you always set it equal to 0. That is a good strategy. But this sort of equation with x and y in actually has an infinite number of solutions. But we're only interested in integer solutions. So it turns it into this just different problem to deal with. It's actually called a Diophantine equation, and we're trying to find the x and y values that work. And one way of doing it is to factorize the x and the y and set it equal to something and then consider factor pairs. So when you set it equal to 0, you're interested in one of the brackets being 0 because one of them has to be. But here, if we got integers, then it must be that this times this, that these must both be factors of 99. That's what I'm trying to get at. So let's write down our factors of 99. We've got 1 and 99. We've got 3 and 33. I mean, I don't need to do a prime factorization. I can see quite quickly all of them. 9 and 11. However, we need to be really careful because it hasn't ruled out negative numbers. So actually, we've also got minus 1 and minus 99, minus 3 and minus 33. So this is probably where you'll go wrong in this question if you have gone wrong, forgetting about them. Okay, and then we can just take each pair in turn. So we can set, we're gonna have lots of different possibilities. So for example, 2x plus 1 could equal 1, and 5y minus 1 could equal 99. And then this would give me x is equal to 0 and y is equal to 20. And so I found an integer pair solution. Okay, while I'm at it, why don't I just do the minuses rather than moving on? So 2x plus 1 is minus 1, 5y minus 1. Now this seems like it's going to take a lot of time, but actually very quickly we start seeing that not all of them are going to have solutions. We're always going to get a solution for x being an integer because 2x plus 1 is an odd number, and all of these factors are odd numbers. However, we've got this 5y minus 1 and 5y, well, 5y is going to be a multiple of 5 is what I'm trying to say. And here, I'm going to get 5y is minus 98, so there's going to be no solutions. So I only have to consider the numbers that are one less than a multiple of 100. Sorry, I think I said 100, but one less than a multiple of 5 for 5y minus 1. It's kind of like obvious because, yeah, that is one less than a multiple of 5. But that's, I'm trying to say, so I've got 5y minus 1. If I set it equal to 3, that is not one less than a multiple of 5. So I don't need to even try and solve it. Let's go with minus 3. Oh, have I swapped them? Oh, I haven't swapped them around yet. Sorry. Let me backtrack. Okay, we got to make sure we get them all. That's the key thing. Right, 5y minus 1, we've set it equal to 99 and minus 99, but I haven't set it equal to 1 or minus 1. Now this one actually is going to work. I'm going to get y is equal to 0. And then to couple with it, 2x plus 1 is going to equal minus 99. So x is going to equal minus 50. So I'm minus 1 from it and divide by 2. Okay, so I've dealt with this and this. Right, 3. That is not one less than a multiple of 5, nor is 33, nor is minus 3, nor is minus 33. So I don't even need to look at the x values for that. Okay, no solutions are found from these. Then I'm just left with 9 and 11. So this is one less than a multiple of 10. So I'm going to get 5y equals 10. Y is going to equal 2. And then 2x plus 1 is going to equal 11. Because remember, I've got these factor pairs. So x is going to equal 5. Okay, another solution found. Then 11 is not one less, so I can ignore that. Minus 9 is not one less than a multiple of 10. It's one more than a multiple of 10. Minus 11 should work. So then 5 my y minus 1 is equal to this. So 5y is going to equal minus 10. And 2x plus 1 is going to equal minus 9. So x is going to equal minus 5. Oh, sorry, and y is equal to minus 2. And those are all my solutions. So to summarize this, I hope I've been clear. We've we've factorized it as suggested, set it equal to 99. This is a really good approach. I've never seen it before. You know, this question's well worth seeing because it's quite a common sort of question in these kind of maths competitions. Um, you will see it again, I'm sure. So we've written down the different factor pairs and then just carefully cycled through them. I've started off by just trying 1 and 99. That happened to work. Then I saw that when I swapped it around to the negatives, it didn't work, which I then decided, all right, can I take a shortcut? Do I need to check every single solution or can I just do it very quickly? And so we only need to look at when 5y minus 1 is 1 less than a multiple of 5. And so I just cycled through them all at this point for my different 5y minus 1s and ticked when they were. And then I found the y and the x that went with it. Okay, crossed it out when it wasn't. I just had to cycle through all of them. Because there's, how many are there in total? We've got, yeah, it's quite a different number because y can equal each of these values. 1, 2, 3, 4, 5. So there's 12 different values that y can take. Okay, this one was okay, this one was okay, and at that point I've dealt with all the factor pairs. So we've got these four solutions. Good. On to the second part. Find all integer pairs such that this is true. Okay, so it's a bit more vague now. It also looks a lot harder, but that doesn't mean it's going to be harder, actually. It just might require thinking about it carefully. So we've got 2x plus 1, 5y minus 1 as before. Now I'm going to have to minus 1 from both sides to get that, so this will change to a 0. And then I've got 8 zeros. It's really useful to write things with commas just to get a feeling for it. So it's 100 million. Now, obviously, there are a lot of factor pairs here. If we try and use the same approach as 99, we might think, how on earth are we going to get this? But it's not going to make us do the same thing again, but just for loads of factor pairs, is it? There's going to be a little trick here. Okay, so be aware of that when you're doing these sorts of questions. And I didn't do the prime factorization before, but I'm gonna do it now because that's actually going to help. We've got 8 zeros. This is going to be 10 to the 8, which I could write as 10 is just 2 times 5, so it's going to be 2 to the 8 times 2, sorry, times 5 to the 8th. Okay, and that is the critical bit for this question. Because when I look at this bit here, this is necessarily an odd number. It's in the odd number format. Okay, it's a multiple of 2 plus 1. It has to be odd. Now over here, this could be odd or even. But here's the thing, there is no way that this can be a multiple of 5. Which means that I cannot set this equal to any power of 5 here, like we were doing before. I was setting it equal to 3 squared, for example. That was potentially okay, but I can't do that. So it must be that 2x plus 1 is equal to 5 to the 8th. Okay, it can't have any power of 2 in. And that, to be honest, is enough to say the other one um, has to be all the powers of 2. But I just explained, I saw that it was the case here as well. So it must be that 2x plus 1 is equal to 5 to the 8th, and 5y minus 1 is equal to 2 to the 8th. I just want to say this again. I've got this 100 million, I've written it down in its prime factorization. It's actually lots 2 to the 8 times 5 to the 8th. I've looked at my factorization. This is an odd number, which means it can't be a multiple of 2 in any way. Because as soon as I times by 2, it'll make it even. So this must be 5 to the 8. It must be all of the odd factors. Couple that with the fact that can never be a multiple of 5. It's one less than a multiple of 5. So it has to be all the remaining ones that that I have, which are not multiples of 5, which is 2 to the 8. And I already know anyway that, I've already taken the 5 to the 8 over here. Okay, so this is the only possible solution. Um, and let's have a look at it. So, we still don't actually know if it will be a solution. 2 to the 8th, actually, like it's worth remembering that I always remember that 2 to the 10 is 1024. So if I halve it and half it again, I'm going to get 256. Okay, so 5y. Okay, I just realized I've made a mistake. So 5y minus 1 is 256. That's not going to be a solution. I've done that thing that I said before. Um, it's not actually 5 to the 8 necessarily. It could also be minus. Must be that or. So there's no solution coming from this one. Or 2x plus 1 is equal to minus 5 to the 8. And 5y minus 1 is then minus 2 to the 8th, which is minus 256. And now we're in business because 5y is going to equal minus 255, and then y is going to equal minus 51. We're left to work out x. So 2x is going to equal minus 5 to the 8 minus 1, and x is going to be minus 5 to the 8 minus 1 over 2. You know what? I'm not going to try and figure that out. It's going to be an enormous number. It's going to be absolutely fine to leave it like this. So after all that, it's actually arguably a quicker answer than part B. But don't forget about your negatives. Okay, one solution to this second part, or the third part of the question.